You pull out your phone, tap the screen, and in a fraction of a second, a high-resolution photo of a dog appears from halfway across the world. It feels like magic. We even use magical words to describe it, like pulling files down from the cloud. But that cloud is actually a physical place. What you are really using is a massive web of wires. Millions of miles of thick cables are buried right under our sidewalks and resting on the sandy bottom of our oceans. These cables cross continents and dive underwater, eventually meeting up in humming rooms filled with racks of physical hardware and densely packed glass fibers. You are looking at the largest, most complex physical postal system humanity has ever built. If you want to mail a birthday card to a friend, the Postal Service needs to know exactly which house to bring it to. The internet works the exact same way. This digital street address, your IP address, tells the network exactly where you are and where the data needs to go. Every single device that connects, your phone, your laptop, even your smart fridge, needs its own unique address to participate in the network. The entire illusion of an instant digital connection relies on the system knowing the precise location of both the sender and the receiver. Now, imagine you wanted to mail an entire, fully constructed physical house to the other side of the world. If you tried to shove that giant, intact house down a single road, it would take up all the space. No one else could use the road until your delivery was finished. A massive photo or video file would do the same thing to a digital cable. This was the major flaw of old telephone networks. A single conversation tied up a whole physical wire, locking everyone else out. To let billions of people share these cables at once, the network has to move data using a completely different approach. The system handles this by shattering that data into tiny, manageable pieces before it ever enters the cable. It's like shattering that massive house into thousands of identically sized bricks. Each brick goes in an envelope, and the system stamps every single one with its destination and return IP address. These envelopes flow alongside billions of other messages without ever blocking the road. This packet switching process allows thousands of these digital envelopes, or packets, to move through the cables at once. Massive files never actually travel across the world in one piece. They move as a decentralized swarm of thousands of independent pieces. Inside the physical cables, these envelopes zip toward their destination. The internet is a maze of intersections, and each packet must find the fastest path. The routers at these cable intersections act as automated postal sorting offices. As thousands of envelopes fly in, the routers quickly read their addresses and act as traffic cops, sending packets down different paths to avoid digital traffic jams. This on-the-fly sorting means there is no single point of failure. If a cable gets cut by a construction crew, the mail simply takes another route. Eventually, this swarm of envelopes reaches its final destination, your phone. But because they took different paths, they arrive completely out of order. Your phone is suddenly handed a chaotic pile of thousands of digital bricks. The receiving device uses a protocol, a strict shared language, to read the stamped numbers and snap the bricks back into their original perfect order. These strict sorting rules ensure you receive a functioning file instead of a pile of useless digital rubble. This entire process, the breaking down, the sorting, the routing, and the rebuilding, happens in a fraction of a second. Millions of tiny digital bricks just flew at the speed of light through cables buried under oceans and continents, all to display one single image on your screen. The world's fastest, most collaborative physical postal system is working tirelessly beneath our feet.